We are the pioneers of the bone marrow transplant, and we are a center for immunotherapy in the world, and that's using a patient's immune system to cure cancer. We also have a huge expertise in viruses and virology, which is why we sort of ran the trials for 4 major vaccines. These include the Moderna, the AstraZeneca, the Johnson & Johnson, Novavax, and coming soon to a center near you, possibly, the Sanofi Pasteur as well. We also are a center which tests treatments for COVID to try and make it less deadly. And we are ever so grateful to supporters like you who have been following our mission and following our work and supporting us along the way. So that's who we are. And I'm here to talk any and all science. There's a researcher at the Hutch called Taran Gujral who has recently used machine learning to try and figure out a treatment for COVID-19, and he can use the same machine learning technology for cancers and other diseases as well. So every cell in our body responds to signals, and somehow those signals have to be converted into some sort of action. And so there are these master on-off switches called kinases that turn on different circuits in your body, if you will. The problem is that there's like hundreds of kinases in your bodies that all look very similar. Some are turned on more in some cancers and some diseases versus others. And you want to try and shut them down to try and figure out which one is really leading you down a bad path. But the problem is, because they look so similar, the drugs that exist will block like multiple kinases at the same time. And so what Taran is able to do is sort of use multiple approved drugs that are in the market and therefore cheap to basically test in random combination to sort of get a picture of all the kinases that are being shut down, to then hone in on which drug combination or which drug in particular can shut down the kinase that is responsible for your condition. We can't talk about booster shots without talking about the elephant in the room here, which is the Delta strain of the virus. Delta has really come in and upended a lot of what we thought we knew about this virus and how we were dealing with it. The Delta variant transmits so rapidly, it's become the dominant strain pretty much all across the world. I think 87% of all viruses sequenced around the world are Delta variants or variants of Delta. And so it's really changed a lot of how we think about the virus and how we think about the pandemic, partly because people who are vaccinated can still catch the Delta and still transmit the Delta variant. And you compound this with the fact that we're discovering that with time, for certain vaccinations, people's immunity fades. So basically, what's happening is that the combination of the Delta and waning immunity means that boosters are definitely necessary. And what's likely to happen is we will need an annual booster for COVID going forward. Just like we get a flu shot, we will get a flu and COVID shot every year. There's multiple different types of treatments. And so I'll say that Fred Hutch launched the first of its kind COVID-19 Clinical Research Center, where we are testing treatments either pre-exposure or rapidly post-exposure to reduce the risk of serious infection, serious hospitalization, and death. The first out of the gate, which we heard about even a year ago, were these monoclonal antibodies. It's basically when you get a vaccine, your body makes antibodies to fight the virus in your body. This is basically skipping that step of vaccination, just getting antibodies and injecting it into people. The problem with monoclonal antibodies is they need a registered nurse and infusion by IV over a few hours, and it's not readily available and readily accessible to everybody. And so that's where we're getting to this next class of drugs, the drugs that can be prescribed by a pharmacist, that can be gotten as a pill. These pills are going to save a lot of lives, especially in places where they don't have good access to healthcare and access to hospitals. The reason we were so successful in launching clinical trials for the coronavirus vaccines is because we've spent years building this network for the HIV vaccine trials network. And we have centers across the world that are using these, we are testing different vaccines for HIV and almost trying to be strain specific and trying to identify 2 or 3 of the major strains that are in the region and putting together a way to develop vaccines that would really be able to convince your immune system to make antibodies against the dominant strains and make these things that are called broadly neutralizing antibodies, which can neutralize many different strains of HIV at the same time. So we have a few different HIV vaccine trials that are currently in the field. And it's been hard because the thing with HIV is it's a sloppy virus. It makes a lot of mistakes when copying itself. And when it does that, it changes fundamentally that our immune system can't see it. And so its sloppiness is its greatest gift, which is why it's been so challenging to make vaccines for something like HIV. Not yet cancer. The idea is that in the case of viral infections, your body's immune system is already surrounding the virus. It just doesn't have the tools to fight it. And the mRNA vaccine gives your immune system a tool to fight it. With a lot of cancers, your body doesn't lack the tools per se. It's just it doesn't see the cancer. And finding a way for it to see the cancer and have your immune system swarm the cancer, then using the vaccine could be very helpful. I think we're still a ways away from using it for cancer, but definitely for viral infections. I think it's going to be a game changer. 20% of all common colds are coronaviruses. So the hope is now that we have developed the technology for COVID, we can also get rid of 20% of all common colds. And, that would be very good. So I'm looking forward to the future with mRNA vaccines. But again, I do want to be very cognizant of the fact that mRNA vaccines, where you head towards a world of like precision medicine, and what does precision medicine mean and who does precision medicine serve? I think that's something we should always think about, like who is benefiting and can everybody afford it? If it's not cures for everybody, is it really even a cure? One of our lung cancer researchers, Dr. Alice Berger, is really asking the question, what is the origin of lung cancer in never smokers? Because there's a large number of lung cancers that are starting to show up now of people who have never smoked in their lives and they still end up with lung cancer. And so she's being able to go back and mine the Women's Health Initiative data, which was looking at these postmenopausal women and just tracking them yearly to understand what habits they have that increase or decrease their cancer risk, because the fact remains that lung cancers in never smokers disproportionately affects women over men. And so she's really trying to understand the origins of that and what are the genetic signatures of those lung cancers in never smokers. And on the flip side, Dr. McGarry Houghton is trying to understand how certain lung cancers almost make your immune system turn against your body or sort of co-opt your immune system to serve as protectors of that lung cancer, and how they can try and identify the right immune cells that are likely to turn against you and then treat them to make it easier to treat the lung cancer. So nexttrain.org is an open source platform developed by Trevor Bedford, a researcher at Fred Hutch, in collaboration with other researchers at the University of Basel. It's a tool where basically they look at sequences of the genomes of viruses and build family trees and try and figure out, okay, this virus came from this one, which came from this one. And by doing that, you can track how a pandemic is moving or a virus is evolving as it moves through the population. For his work tracking COVID, Trevor Bedford just received something that's called a MacArthur Genius Grant. And actually, for this entire audience, you can hear more from Trevor Bedford at a Fred Hutch event called Science Says. And Trevor Bedford will be interviewed by none other than Trevor Noah, host of The Daily Show and comedian from South Africa. So if you want to go to fredhutch.org/science-says, you can listen to Trevor Noah interview Trevor Bedford and a couple of other Fred Hutch researchers. pancreatic cancer is a broad term. It's the cancer of the pancreas, but there's many different types. The way cancer originates for one subtype is different than the other, and so the treatments are different. One of our researchers, Dr. Sita Kugel, studies pancreatic cancer, and she and her group are working to recreate the different subtypes of pancreatic cancer to better understand the signals, that the master regulators that turn off and on the switches that convert healthy cells into the two different types of pancreatic cancer. And if she can figure out the master regulators, she can then shut down that transition from healthy cell to pancreatic cancer. On the translational side, Dr. Phil Greenberg is learning how to reprogram T cells, your body's immune cells, to recognize a protein that is made in huge abundance in pancreatic cancer cells called mesothelin, and trying to figure out a way how to engineer those T cells, not just to recognize the cancer cells, but also to make it past the barriers that the pancreatic cancer puts up that just sort of shuts down all immune cells. So he's got a lot of tricks that he's building in that sort of try and turn the tables on the signals that the cancers use to try and shut down the immune system. So Rachel Isaka, who's going to talk to Trevor Noah on November 30th, one of the things she advocates for is catching colonoscopy early. There's a huge variance in outcomes depending on whether you catch colon cancer early or you catch it late. And a lot of people don't want to get a colonoscopy, and so they don't get screened. And so invariably by the time they catch the cancer, it's a really advanced stage. And so there's a lot of stigma around colonoscopy. It's also hard. A lot of people don't have access to it. And so she's championing this mailed test called the FIT test, where basically it takes stool and it's able to identify potentially whether you have colon cancer growing. And so she's really trying to push more access for all and better screening and reducing the barriers to screening to then potentially maybe take care of one of the faster rising cancers in America now. The microbiome is a collection of bacteria and viruses that live on our body and in our body. We have 30 trillion cells in our body. We may have 300 trillion microbiome bacteria and viruses on our body. So we are more bacteria and virus than we are human. And so the implications are massive because our body comes to sometimes rely on the microbiome. When we eat certain things, our microbiome will break it down a certain way, and then we will take the byproducts. And we rely on the byproducts of the microbiome in our body for certain nutrients. Alternatively, our immune system knows not to destroy certain microbiome elements or components. But what if we get infected by a bacteria or virus that looks just like a component of that microbiome? Will our immune system stand down? Or is that why we have autoimmune diseases? So there's just so many elements to the microbiome that understanding it can really unlock how we think about disease, and maybe complex diseases like autoimmune issues that we still don't fully understand why we have them yet. It's hard to predict what the next big one is going to be, but I know we've covered a lot of bases at Fred Hutch. The one I would really like to talk about is our herpes work. Fred Hutch has one of the world's leading herpes virus researchers, and he's getting ever closer to developing a cure for herpes. Basically, he's been able to engineer a pair of scissors that can go where herpes is hiding in the body and cut the herpes genome and either destroy it or force it out of hiding. The conventional therapies can take care of it. And so he's trying to get together funding right now to launch a clinical trial to test for this cure for herpes. And, almost half the planet is living with some form of herpes. And so this cure would be the first time that we have something to treat half of the planet.